got that because 70 plus 60 plus 50 is 180. Looking for x. Okay, so Victor, let's pretend that the x is actually a. So we're going to put the x where the a is, all right? What angle goes underneath? Sine 70, yeah. Pick another side that you know. That's an angle, just the side first. So what's the side? 10, and it's divided by. All right, now the deal is I have to get x on its own. How'd you do that? So it's 10 sine 70, yeah, over sine 60. Prediction time. If 60 degrees looks at 10, what do you think 70 degrees looks at? Just a rough estimate. Bigger than 10 or smaller than 10? Yeah. And what do you get when you put it in, Luke? Anybody else get 10.85? Yeah. Right, excellent. Right. Too easy for you, right? Let's move on. So there are length questions. That's question 5. Okay. Next we're going to do is question 6, which is an angle question. Okay. This one here. Okay. So let's see what we can do with it. Okay. There it is there. Make it a bit larger. Okay. An angle question. Now, what was my advice when I was telling you to do angle questions? What you do with the formula at the very beginning? Yeah, if you flip the formula at the very beginning, it's easy enough to pull off. Okay, so you're using a over sine a equals b over sine b, but instead, because it's an angle question, not a length question, you can turn it upside down if you want. It just means there's a lot less work in it. Okay. So Kenny, we're looking for a here. See a. What side is opposite a? 12. So what's the first thing I can write in the calculator? What can I write in the formula then? Nearly sine a over 12. Do you see the way the sine's on top? See the way I flip the equation upside down? So this is your original equation in red, right? That's what you're given in your log tables is in the red box. Because I recognize it as an angle question, I turn both sides upside down and start with what I have in the green box instead. All right? You just turn both sides upside down, makes the whole thing a lot easier. Okay? Then what I do is I look at the angle I'm looking for. I'm looking for A, so that's sine A. And then underneath sine A is small a, which has to be 12, because that's the one you're looking at. Okay? Then I go equals, what other angle do I have? So I call that sine B, so that's sine 140. And what side does that look at? Exactly. Now, Sean, because this is a angle question, what way does it have to end? Sine inverse, isn't it? Okay. So what happens to the 12? Where does the 12 go? Yeah. If it's division on the left, it becomes multiplication when you move it to the right. So it goes to the top. So it's going to be 12 sine 140 over 25. Put all that into the calculator and see how we go. Okay, so put it into the calculator. And how are we getting on with it? So I'll highlight the part you're going to put into the calculator. Just put this part here into the calculator and let me know what you get. Throw it in. Maybe about 3 decimal places will do it. What you get, Roger? 0.08. All right, prediction time. If 140, yeah. Give me a look. Fraction button 12, sorry, 140. Yeah, 7. I'll show you. So you press the fraction button at the start, then you press sine 140, and then you go to the right and enter 25 on the bottom, like that. And I got 0.0308, 5, so 0. I'll put the 5 in as well. Okay. I don't like rounding up to 5 because it's halfway. Now, lads, prediction time. 140 looked at 25. A looked at 12. Should it be a big or a small angle? Should it be below? Should it be bigger than 140? No, it's going to be quite small. So there's a button for this, okay? And here's the button. When you're doing an angle question, and you're left with this, to separate the sine and the angle, you use a button called sine inverse. Okay? And this tells you what angle you're looking for, because it is an angle question. So you go to your calculator and you press Shift, sine inverse, and then you put in that number. So you try that out now. And I don't have an answer. Huh? 17.97, yeah. I won't call it 0.9 because it's round upwards of anything. It'd be 18, 17.9. Who got that? Okay, so previous, we'll need a bit more work on the angle ones then. So let's go again. Okay, so we try this one now, lads. Okay, so you put in your original formula, which is this is ideal for a length question. There you go. Wait a minute, I'm doing an angle question. So what happens? Flip it. Now you can label them all if you want. Could be a helpful one. If that's capital A, this one here is small a. The only result you know is 14, isn't it? And then this one will have to be big B, won't it? Yeah. Lob them all in. Let's see what happens. Sam, you have an answer for this, yeah? Yeah, sounds about right. Just slightly bigger than the 44, isn't it? All right. So, yep. What is it? I'm losing my own brain here. Bring that 16 upwards, is it? Over your 14. What do you get when you put that in the calculator? Oh, you sine inverse the whole thing, do you? Do you actually do this, do you? Shift sine inverse and you do the whole 16. That's better, by the way. I just thought it wouldn't be I just didn't think it'd be a good look. So you do that. That's awesome. Well done. That's actually more accurate. So 53.22. Yeah. Because it's an angle question. Remember, so I switched over both sides. Yeah, you're right. I switched both sides. So I don't know what big A is. Yeah, I don't know what big A is, so I just left it as A. But I know I looked at the 16. So did everybody get A is either way 53.223 or 53.2? All right, I reached the stage. It's a bit easy. Okay. All right, try and find something a bit more taxing for you. All right, have a quick look at question 12. Does anybody know the goal of the question? What is the goal of this question? Calculate the area. Everybody see that? Okay. Can anybody tell me why I can't use a half base times height? So usually at the unit level, the area triangle is half base times height. I need to know this right here, wouldn't I? I'd also need to know the base. And that won't work for me, right? So I'm going okay. we do here. There's option B. What's option B? You learned a couple of days ago. The formula for the area of a triangle. Half AB sine C. All right, so that's option B. Now, when you're using a half AB sine C, what you need is two lengths. Do we have two lengths? We have these two lengths here, don't we? And you also need to use the angle in between. Do we know the angle in between? No. Okay, so that means that is currently not usable. If you wanted the net marks, and let's say without doing anything, that is a valid attempt. Because what have you done? You've attempted to fill in the equation, haven't you? Okay. Now what we're going to do next is, right, is there any angle we could get? Is there any angle that's obtainable for us right now that we could get using this sine rule? We could try getting this angle here, don't we? Call that big A. So what I would do is I'd find out what big A is. I'd add the two angles together, and then I'd find out what angle X is. And once I found out what angle X is, I'll just plot it up in here. Does that make sense? So use the sine rule to find angle A, and then find out what angle X is, taking away from 180, and then do the area of the triangle. Sine A over A, you're going to use that formula there. That's going to be big B, that's going to be small b, that's going to be small a. 22.28, I'll have a look now. All right, so did we do sine A divided by 80 equals sine 40 over B, which is 120. So I think that's what you're talking about. See that 80? It's division on the left, makes a multiplication on the right. So it's going to be 80 sine 140 divided by 120. No, look, the sine 40 is on the top. The 80, it was on the bottom on the left. It's division on the left. Oh, 140. Oh, sorry, it's meant to be 40. Thanks. So that's my bad. Yeah, go on down. All right, guys, you throw all that into the calculator. 80 sine 40. All over 120. 0.4285. And you sine inverse that to get the answer. And what answer do we get, lads? When you sine inverse that? Huh? 25.3. Yeah, or 25.4 if it rounds off. Now, so Gavin, you remember at the start of the question, we were using this formula here. And the only thing blocking us from using the formula in the yellow was the fact that we didn't know what the angle was. The angle was the only thing stopping us. Is there any way we can find out what angle this is now? How would you figure out what it is now? 180, take away the 40 and the 25.4 you just got. So 180, take away the 40 and the 25.4. And you get, what's it, 114.6. And then, so we can rub that out and put in 114.6. And then throw all of that into the calculator to find out what is the area of your triangle. And we got the area yet? What you get? 4,000? Yeah, 4,315. All right, should come out, I'm hoping. Gonna find out now. 4,364.3 to the nearest square meter. Always read the fine print at the end. So 4,364 meters squared. We go. All right, guys. We decided to go for the sine rule upside down again. I'll call this small a because it's looking at large A. I'll call this small b because it's going to be looking at what I would call large B. That cool? So we fill it in. Then we get sine A over 15 equals sine B, sine 50 over 25. What's our prediction? Is A a bigger or smaller angle than 50? Huh? Small has to be smaller, doesn't it? Looking at smaller sides. What happens to the 15 thing? Sorry, it's already drawn 50. So 15 sine 50, yeah. All over 25. Put down to the calculator what you get. Yeah. Roll. Just put your name on it. Yeah, pass it on. Yes. I'll show you in a second. The angle that's between the two sides, you know. Uh, 0.4596. Can you have a look at your calculator? You might be in a different mode. Oh, it could be your calculator. No, you're in degree mode. So, sine inverse, my answer, my 0.4596, and we get a 27.36. So, A is 27.36. It also says the nearest degree, so I'm going to call it 27. Now, 50 plus 27 is 77. Get your 180 and take away 77 because that's what you want. 103 degrees. Okay. And finally, to get the area of your triangle. Finally, get the area of your triangle, guys. It's a half AB sine C. So what two lengths are we going to use? Has to be two lengths and the angle stuck in between. So what two numbers are we going to use? You looking? Doesn't matter which one's A and which one's B, does it? No, because it's the same thing. And sine C. And when you put it all in, 182.69, lads. To one decimal place, so 182.69, did you say? Yeah. Is it meters or centimeters? Doesn't tell us. Call it units squared. All right.